Today we want to talk about cycloalkanes and alkyl halides, and they don't really necessarily belong together. It's just I wanted to make one video instead of two. We're going to start with cycloalkanes, and it's important to remember that these are just going to be alkanes. So in terms of identifying functional group, they're just alkanes. So the only difference is that they are in a ring, a cycle. They also then are going to have a couple of fewer hydrogen atoms. So if you look at a comparison between a 6-carbon straight chain and a 6-carbon ring, you'll notice there's 2 hydrogens, not missing, but 2 hydrogens less in making the ring, because I have effectively one end of the chain wrapping around and joining up with the other end of the chain. So I have to lose those hydrogens to make that new carbon-carbon bond. We're going to focus on the nomenclature. The properties of a cycloalkane are going to be the same as the properties of an alkane. So how do we handle the nomenclature? The good news is it's mostly the same. And all we're doing, I have the word tweaks up there, even though it's maybe not the best word ever. But the idea of a tweak is that I'm going to try and do the same basic things I did with alkanes, because that's the same basic thing I want to do with everything. So instead of having the longest chain, I'm going to have the largest ring is the root name. So if I start with the smallest ring I can have, which is a 3-carbon ring, and I'm generally going to write it in a much more condensed form, so I'm not going to include the hydrogens or the carbons for that matter. Every point there is a carbon atom and the hydrogens are implied, so I draw a triangle and I call that a cyclopropane. Cyclo means a ring, prop because it's 3 carbons, and ane because it's because it's an alkane. So everything about that structure, the ring, 3 carbons, and all the carbons are single bonded, is wrapped up in the cyclopropane name. And as I make the rings a little bit larger, I'm going to keep the pattern going. So I'm going to have the notation that it's a ring, the carbon count, and the fact that it is a alkane. And I'm going to draw pictures up to cyclohexane, keeping in mind that you could have longer ones or larger ones. You could have a 6-membered, sorry, I have a 6-membered. You could have a 7 or an 8 or a 9 or a 10. Those ones are a little bit less common realistically, although you're seeing things on paper, so whatever goes. Probably my favorite ones to draw are the cyclohexane, followed by the cyclopentane. So you'll be seeing a lot of those. If we continue with the nomenclature, and our next rule in nomenclature was after identifying the longest chain or the root name, and now it's the largest ring, it was the numbering, because every carbon had a number, because every group needed a number. Well, the nice thing about a ring is I can kind of start anywhere on the ring, so I'm going to start at one of the groups, and then I'm going to try and do the same thing. If I have one group that's more important than another, I will start with it. It will automatically be carbon number 1. So if I take a look at this one, you could argue that that methyl group is not really a priority, but in terms of the root name, it's higher priority than anything else that's on those carbons because they're not written in, they're hydrogens. So that one is going to be a 1-methyl cyclohexane, but because it's automatically at carbon number 1, I could just call it a methyl cyclohexane. It's not too often that you're going to have a single substituted carbon ring. You're more likely going to be having multiple substitutions or multiple groups on that. So something more like this. Now for this one, honestly, I'm not going to worry about it too much. So if you want to start with the methyl group and work toward the isopropyl, that's fine. The best answer though is to start with the isopropyl group because it's a little bit bigger, therefore a little bit more important, and work toward the carbon. Say it again, it doesn't matter to me that much. We're not going to get so much practice at this that everything is going to be, that all the little questions, all the little nuances will be answered. Short answer to that question is, anytime you're asking, well, what about this, what about that, what about that, there's absolutely a rule for it. We probably are going to get to some of them. I shouldn't say we'll probably get to some of them, we will definitely get to some of them, but some of them we're just not going to get to. Anyway, this one, the best answer is 1-isopropyl 3-methyl cyclohexane. By the way, the The one isopropyl, it's the priority group gives the number 1. The order is the alphabetical, so the I before the M. We've also been doing isomers. So what do we do with isomers of cycloalkanes? Well, you're never going to be told it's a cycloalkane. What you'll be told is C6H12. And if you were to try and draw that as a straight chain alkane, because that's a pretty good place to start, and figure out how many carbons you have and how many carbons you need. Sorry, I take that back. Not how many carbons you have, but how many hydrogens you have and how many hydrogens you need. You would find that this one is kind of, again, I don't want to use the word short 2 hydrogens, but you need 2 more hydrogens than you have. You're absolutely not going to leave that as it is. You're just not going to use that one because it's not a proper structure. Every carbon must have 4 bonds, no more, no less, and no exceptions. So one of the things you can do is you can try a ring, because as we saw earlier, rings use fewer hydrogens. After that, we can do the same strategy as we had before. Before it was make the chain smaller and put on a branch. Now we're going to make a smaller ring, put on a branch, and then we're going to do it again, and then we can move the branch. Now, obviously, with the second structure, the methyl cyclopentane, I could not move that branch. I could, it just wouldn't be different. With the 1,2-dimethyl cyclobutane, I've got a couple more options. I could have them both on the same carbon. I could have them on 1 and 2. I could have them on 1 and 3. There's also, with rings, one other kind of isomers that are possible. We're not really going to get into it because it would be very, very difficult for us to do it without being live, let's say. Alkyl halides, and these could be a separate video, except if I'm thinking about doubling things up, maybe I'll be a little bit shorter than I would having them 2 separate ones. That is the presence of a halogen, as you hopefully already know. So a chlorine, bromine, iodine, or fluorine. I missed that one at the front end. Similar to the cycloalkanes, I have a couple of favorites. My favorite is the chlorine, but I'll try and use the bromine fairly often as well, and we'll talk about why that is a little bit later. This now is not just a simple alkane. This changes the functional group. Alkyl halide was one of their functional groups, and that means that the thing that changes the functional group, that gets priority numbering. So if I look at this structure here, and your eyes have already, or your brain has already been trained to look for where the most stuff is. So you would look at that and you would say that the most stuff is down on the left end, so you would want to start the numbering on the left. But that chlorine group, which is more or less in the middle, but just a little bit closer to the right end, that changes everything. So that has to have priority numbering. It doesn't matter what else, how many other carbon groups or how big the other carbon groups are. That chlorine changes the functional group. It gets priority numbering. So we would actually number that from the right end side, and we would call it a 3-chloro-4,5,5-trimethylhexane. I want to point out at this point that, sort of repetition there, I want to point out that for a lot of the functional groups, the ending of our root name will change. So not everything, 6-carbon chain, not everything is going to be a hexane. We'll pretty much always use a hex something, but it won't always be a hexane. But with alkyl halides, we do just treat it as an important group on whatever kind of carbon chain we have. If I give you this one, where I'm combining cycloalkanes and alkyl halides, and I ask you to name that, hopefully you would start with the bromine and work your way to the isopropyl, and you would end up with a 1-bromo-3 isopropyl cyclohexane. Something I don't think I've mentioned already is that that's not even a very big compound, but the name is getting huge. As we end up getting bigger and bigger compounds and our names get really off the wall crazy, we end up using common names. We're not going to, because we want to learn the system, but just so you know, looking ahead. As we get into other functional groups and other types of, not other types of nomenclature, other nuances, other tweaks out of nomenclature, we have to remember that the thing that makes it a functional group, that gets priority. And then this is why I was saying earlier, I'm going to try and use bromine a little bit more often, because the Cl and the CH3, when you just sort of take a quick glance at the compound and make those initial decisions, they can look a little bit too much alike. And I've seen it a lot of times where people will completely miss a chlorine thinking that it was a methyl group. So you want to avoid that because, because it's still a mistake you made, not something that I made. Anyway, that does it for now. Hopefully that's enough to get us going and get some practice. And we will talk to you another time. Stay safe.